In this video, we're going to introduce you to 3D vector formats that are used in statics. There are basically four different ways that vectors are represented in 3D and statics, and you need to know all four forms. The first form is Cartesian vectors. And so if you have a general vector in 3D space, you can resolve that vector into an fx, an fy, and an fz. And so you can write the vector with the ijk Cartesian unit vectors, or like the calculator represents it, you can just put them in as fx, fy, fz within square brackets. To enter it into your calculator, you're basically going to take, so if I have a 10, 20, 30 vector, I would just go control, square bracket, 10, comma, 20, comma, 30, enter. And if my display format is listed as rectangular, then it'll display in Cartesian forms just the way I showed it. If I want a unit vector for this guy, I can go to my functions. I can look up U. I can scroll down unit vector, enter. I can control V copy, so control C, copy that vector. And then I can control V, paste it into this unit vector function. And this gives me a unit vector for that guy. If I want the length of this vector, I can look up the norm function. So I can go to my catalog. I can click N. I can scroll down to norm. And I could control V paste this vector and hit enter. The length of this vector is 37.42. That's its norm. Or that's the square root of the sum of the squares of the components. I can take this 37.42 and divide it into the 10, 20, 30. So if I do that, if I go up and copy this 10, 20, 30, control C, copy, come down here and control V paste, and I can divide by 37.42, 37.42, which is the length of the vector. I get the unit vector, which I just found. And so you should be able to enter a Cartesian vector, find its length, find its unit vector, and work with it. So that's a Cartesian vector. Another form of vectors in 3D that you'll see are called coordinate direction angles. And so you'll see a vector out here in space, and you'll see an angle from that vector directly to the x-axis. You'll see a vector from an angle from that vector directly to the y-axis, and an angle from this vector directly to the z-axis. I call them alpha, beta, gamma. Some books will call this theta x, theta y, and theta z, or some other notation, but I prefer alpha, beta, gamma. And again, these angles are measured directly from F to that axis. And so remember, if you look at this F and the x-axis, you can put a plane where both of these vectors lie in that plane. So you basically have an F, and you have the x-axis. And if you know the angle between that F and the x-axis, which is alpha, then the projection of F along the x-axis is F cosine alpha. You can do the same thing for the projection of this force onto the y-axis. It's F cosine beta. And finally, the projection of this vector onto the z-axis is F cosine gamma. So these are the projections of those guys. Because the cosines are the projection of this force onto these axes, Sometimes we call these direction cosines. So you can call them coordinate direction angles, or you can call them direction cosines. So if you write this f cosine alpha, f cosine beta, and f cosine gamma, then you can write the f vector as equal to this guy in the x direction, plus this guy in the y direction, plus this guy in the z direction. You can factor out the f, and so you get f is equal to cosine alpha I, cosine beta j, cosine gamma k. And then if you divide both sides by f, the magnitude of this force, then on the left-hand side you get an f vector divided by an f magnitude, and so that's a unit vector on the left-hand side. And so the unit vector of this guy is equal to cosine alpha, cosine beta, and cosine gamma. Because this is a unit vector, he has a length of 1. And so if you have a vector that's got a cosine alpha, cosine beta, cosine gamma as your three sides, then the sum of the squares of those guys has to be 1. Well, what that means is if I know any two of these angles, I should be able to find the third. And I'll show you that here in a moment. And so technically I only need two of the angles, but I really need a picture though, and you'll see that here in a moment, to know whether the third angle is in the positive side of the xy plane or the negative side of the xy plane. In other words, whether gamma is less than 90 or whether gamma is greater than 90, which you'll see. So those are coordinate direction angles. And let's work a couple problems with those. So here's a problem. So this is a x, y, z coordinate system. You're given alpha is 60, beta is 45. You can tell from the picture that gamma is less than 90 because this vector is above the xy plane. But we don't know gamma. And so the first question is, what's gamma? So remember, we can write cosine squared alpha plus cosine squared beta plus cosine squared gamma is 1. Well, cosine of 60 is 0.5. And so 0.5 squared, which you should have memorized, and then 0.5 squared is 0.25. Cosine of 45 is 0.707, but you square that and you get 0.5. Finally, cosine squared gamma we don't know, and that's equal to 1. So cosine squared gamma is equal to 1 minus 0.5 minus 0.25, which is 0.25. In other words, cosine squared gamma is 0.25. So if you take the square root of both sides of that equation, you get cosine gamma is equal, and the square root of this guy is either positive or negative 0.5. So the inverse cosine of positive 0.5 is 60. The inverse cosine of negative 0.5 is 120. So in other words, gamma can be either 60 or 120. So how do you know the difference? Well, basically, you must go to your picture and see what's going on. And so again, gamma can be 60 or it can be 120. In other words, this vector could be below the xy plane. It could be down here. And in that case, the gamma would be 120. But in this case, it's 60 from the picture. And so finally, I want to write the f vector, and that's equal to the 80 magnitude times the unit vector, which is cosine alpha, which is cosine 60, which is 0.5, cosine beta, which is cosine 45, which is 0.707, and cosine gamma, which is cosine of 60, which is 0.5. And so F times those guys gives me 40, 56.6, and 40 pounds. And so this is a pretty vanilla, pretty straightforward coordinate, direction, angles problem where you're given two of them and you're asked to find the third.